Thank you. Welcome. Welcome everybody to Rohde Schwarz. Well, I have given this presentation already once before, and actually I wanted to refactor a couple of slides and change the structure a little bit, but I haven't found the time to do so. So if you see anything that is a bit off, please just consider that legacy content. And yeah, why do we always find excuses, right? My name is, let's talk a bit about that, and in a more keynote-ish kind of way, to warm our brains up a little bit and have a bit of fun with the topic that affects all of us. Probably all of us have said this sentence at least once in our lifetimes, or at least heard about that sentence coming from a colleague. And yeah, my name is Sautter. I work for Rohde Schwarz. I am probably like you guys. I'm a coder, basically, sometimes a lead software projects, and I'm also a trainer for Rohde Schwarz. I've created an in-house training program that deals with how to make code more maintainable, basically. I talked about that topic with fixed software teams. And today I try to draw a little bit from that experience and yeah, talk with you guys a little bit about this topic that affects all of us. You know, let's start with a situation that we're probably all familiar with, which is you are the new guy on the team, right? So they show you the code. That's my code base. Everything's working perfectly. Do not touch anything. Yeah, right? Obviously, you have to at some point. And while they show you the code base, you notice some things that feel a bit weird. You know, they spend a long time trying to find the things they actually want to show you. They have a lot of big files with weird names you don't immediately recognize, and you get a bit suspicious. So after they've introduced you to the code base, you get back to your desk and you take a look at the code base yourself, and you discover legacy code, right? So many large files, big procedures that are very complex, a lot of nested conditionals, a lot of nested whatever that's hard to understand, and code that exists since decades probably. And obviously the feeling that comes to you is you already are afraid of touching this big pile of mud where everything seems to depend on everything. And this is your first day at this team, so not the best way to start. Our initial impulse when we encounter code bases like that often is, oh God, we need to rewrite everything. We call this refactoring. Actually, it's not, but who cares about the definitions? So we need to rewrite parts of the code. And obviously, in any economic setting, this is not possible to just, start your job and just rewrite the whole thing, because it's not in the state that you would like to have it in. But since probably you are an experienced programmer, you know that very important skills for programmer is actually negotiation, because often we see problems and we have to negotiate for time in order to really make things better that are really maybe not so good and shouldn't stay that way. So you talk to the manager. Obviously, first answer is we have no time. You negotiate a little bit and they say, okay, customers are waiting. We have to develop those features and stuff like that. But okay, you get one refactoring sprint. Okay, one sprint, whole team, only refactoring. After that, we continue with the features. So pretty good outcome. But now you have a decision to make. And that decision is a pretty important one. And the decision is what to refactor in that one sprint, right? You cannot refactor everything. It's a big code base. How do we select the things that we should refactor now in this sprint? And this decision is pretty important, right? Because it will have a lasting effect on your job satisfaction for the next couple of months, right? So you better refactor the right things and not the wrong things without really knowing this code base so well. So there's a problem that's interesting. And we can lean on other disciplines, for example, investing, if you will, to see where should we now invest this time that we have. And we can, for example, you probably all know this formula of the ROI, the return on invest, which is the amount gained minus the amount spent divided by the amount spent. Okay, now, very trivial. So now you say, David, this is easy. come on, don't bore me, you know, amount spent, easy, we do a little planning poker, and we calculate some story points and so on. But wait a minute. How do you calculate the amount gained from a refactoring? So, what do we actually gain from a refactoring, and how do we quantify that? It's not so easy, right? And, sorry? Okay, later maybe. If you have a good idea, please keep it, and we can talk about it later. So what do we gain from refactorings? Well, initial response might be, okay, the code is more beautiful, but that's not really the goal. That, you know, if you're working in your free time on an open source project, maybe that's interesting. But if you're in an economic setting, working at a company, we need to quantify that with money, basically. So, if we refactor stuff, obviously we want to avoid costs that otherwise would be created in the future. We want to avoid costs in the future. And then the second question is, okay, good, we want to avoid costs, but where are the costs coming from? And it's interesting to look at that, because there are studies about that, where the costs actually come from. One of the studies is this one. Maybe you have seen this graph already. It is a study with the creepy title, I Know What You Did Last Summer, an investigation of how developers spend their time, by Roberto Minelli, Andrea Mocci, and Michele Lanza in 2015. And what they did is, you know, they took all this fine-grained IDE interaction event data, basically complete surveillance of developers, right? But with agreement, obviously. And they did that for a couple of different developers, different software teams, and pretty much on average what was the outcome was this. So if you look at the graph, this is very interesting. Okay, we spent around 4% with navigation, around 5% with editing, 8% with drinking coffee, 14% UI interactions, and 70% understanding. I think that's a pretty interesting outcome, because intuitively I would have said, okay, yeah, probably understanding is a big part of my work, but I wouldn't have said it is almost 3/4 of my work, intuitively. But that's what they found out. And
how do you measure understanding? You know this?
I didn't really know how they measured that, but they could obviously separate it from the other actions as well. Yeah, that's a good question. But probably scrolling through files and reading like that, yeah. Could be, yeah. There's probably an event for that, yeah. Fell asleep at the desk. Okay, so we noticed that understanding the code is actually where a lot of the costs come from. This is also what other people say who are, you know, Uncle Bob or something like that. They say, you read the code all the time. This is where you really need to take a look at when you think about the costs that will be created by this code in the future. It gets written one time, it gets read 1,000 times, for example. Now, okay, so this is where the costs come from. Not the babies, they are also expensive, but the reading. And the consequences of that are basically twofold. So the first consequence is that obviously in a talk about refactoring I have to cite Martin Fowler, which is obvious because he wrote the refactoring book. And he was one of the persons who said, okay, any fool can write code that a computer can understand. Good programmers write code that humans can understand. Yeah. We know that. But we don't follow that all the time, because what that actually means is, okay, we know that the programming languages is kind of optimized for humans to understand. It's not so much optimized for the computer to understand. They need a compiler for understanding that and stuff like that. Good. But there's a part that sits even on top of this, right? Getting my mental models into code and designing the classes and everything. So that part is really our burden to write in a way that other people can really quickly understand what is going on here. At least if you're working with other people. Obviously, if you're working for yourself, then it's just something, well, maybe you will be thankful for in a couple of months. But okay, how can we measure this? Many people think they can judge themselves whether their code is readable. I would suggest get this idea out of your head. Because the most reliable judgment is you just take the code, put it in the hands of another program, and say if they can understand it. What we do in our team sometimes when we do code reviews is I take the code that was just created by another person, I read it, yeah, obvious, yeah, understood, huh? And then I get stuck somewhere, maybe some complex expression, maybe some nested conditionals or stuff like that. And when I notice that I take more time than usual to understand this, I just make a little comment there, I got stuck here while reading. Right? No suggestion, no, we can talk about that later. But I just want to conserve this information that this code will probably also create a lot of costs in the future, at least relatively to the rest of the code. Because if I take a lot of time to understand it, other people will as well. It is kind of a thing, you know, many people don't do that because they think, okay, what does that say about me as a programmer? Maybe I'm not smart enough to, you know, you should have understood this line of code, it's easy and stuff like that. But it's good to have an atmosphere in your team where you can just easily do that. So I found that very helpful. And that means, okay, we do code reviews. A lot of teams, if you don't do code reviews, it's a good idea to start them. But it also has a second consequence, and that is we wanted to clarify which parts of the code base we want to refactor first. So we need to refactor those code bases which are hard to understand, those parts of the code which are hard to understand. And now we have a big code base. We need some measurement for each file, for example, if this is hard to understand, and obviously that's a metric. Now I know that metrics are fallible, and they can lead you into the wrong direction, but humans can do so as well. Human opinion is no more precise. So a metric is just an idea of what a bunch of humans thought a good metric could be, and obviously we could use it for a case like that. So we could use any metric you have at hand for complexity. Now that could be, you know, some advanced sonocube, cognitive complexity calculation. It could be cyclomatic complexity, ABC metric. It could even be lines of code. They all scale pretty much equally. For such an analysis, it's not a bad idea also to use line of code. You just use what you have at hand in your technology. But then, when we think about will this code really produce costs in the future, complexity is not enough. We need a second piece of information. And the second piece of information is, will we actually have to read this file in the future? Right? Because just if it's complex, if nobody needs to take a look at it, who cares? It won't pay off to refactor that. So what we need is an indicator, an approximation for will we read this file in the future. And it turns out for large code bases, there's kind of a hidden rule that what we touched recently, we will also touch in the near future. So over a certain time span, things that change, they tend to change also in the future. And things that don't change, they also tend to not change in the future, over a broad scale. And what you can do, obviously, now is you can, okay, for example, just look at the number of commits per file. And the number of commits per file, maybe from the last 6 months, maybe from the last year. And you can just add this information to just estimate whether we will touch this code in the future as well. And this is called the churn. So now you have two dimensions, basically, and you can draw them on a graph and make an X for every little file that you have in your code base. And this technique was first introduced by Michael Feathers, who wrote the code about legacy code, the book about legacy code, in a blog post from 2011 about getting empirical about refactoring. And in this graph, you can kind of see 4 quadrants, right? You have the lower left quadrant. And this quadrant, you have files that are easy to understand and they rarely get touched. Nothing to do here. In the lower right quadrant, you would have files that get touched a lot, but everybody understands them. So they are also not a priority. In the top left, you have complex files that rarely get touched. This is the trap. We often refactor those files, but if you think about it, it would take a long, long time until that refactoring pays off, assuming that we won't touch them in the future. If we know that is a different thing. If we know we have to touch this file in the future due to some information, that's a different thing. But as I said, this rule mostly holds true. So Those files take a long time to pay off. Maybe they don't pay off at all. So I would really focus, and that's what also what Michael Feathers suggests, is focusing on those files that you see in the middle and in the top right quadrant. And I did this analysis with one of the code bases I work with. It looks like that. So I have a couple of files, and obviously when I hover over those files and I see the file name, I know, oh yeah, that file, oh yeah, really, I know that file. This is the thing that I'm procrastinating on refactoring since 2 years, and I really should do that, yeah. You could also call it the Death Star file. They actually made this analysis for a couple of open source projects, and it turns out that most code bases look the same in this picture. Yeah? There's always some Death Star. There's always some file or a couple of files, like here, the 5 files or something, that would be worth refactoring under this metric. Okay, there are even some people who suggest to take a third dimension into this analysis, which would be the coverage of the file. I'm not necessarily a fan of that because it makes things unnecessarily complicated. And I don't know if coverage is really a good indicator whether you should refactor something or not. But it's open for discussion. Some people suggest it. And obviously, such a script that can plot something like that for you, you can just let it be generated by ChatGPT or something like that. It's pretty much, or you can write it yourself with anything you like. Okay, interesting. Now we have an easy method to judge and to select files that we can be pretty sure about they are worth refactoring in this one refactoring sprint. So now some confidence comes into play, right? Refactor man. So, and obviously this will not catch everything that is bad about this code base. So there's obviously things that are more structural, that maybe hide between different files, that maybe are related to some libraries that you're using, and maybe it's just spread over the whole code base. And you just notice them while programming, basically. So there's the time after this first refactoring sprint where you will notice pain that was hidden before, basically. Now what do we do with that typically? Well, we grab a colleague, we go into the kitchen, we drink a coffee, and we say, "Hi, did you notice the way that we retrieve data here? Yeah, I had to touch like 5 files in order to change that. It's really a pain in the ass, and how do we..." And you say, yeah, we should change that one day. We should change that one day. And then we go back and we just develop features and features and features. And fix bugs, obviously. So we tend to, not act on those things, and they tend to just stick in the code base for a very long time. And I wonder, sometimes, developers go to the manager and say, "We have this big problem," and they say, "Where's the problem?" And you say, "Oh, difficult." And there's a nice tool that I found on the internet, or a nice little thing that we also do in our team, in order to catch those things, basically. Easy little thing. And it is called the yak log. Maybe you have heard about that. It's also called the wall of technical debt. I have it from Matthias Verais, from a blog article. And what you basically do is you take a physical wall, so not like this, you take a physical wall, like a whiteboard or something, you put it in the middle of the office where everybody walks by every day. And the rule is basically when you encounter such a problem that is kind of, annoying while programming, you take a little sticky note, you write the problem on it, you put it on the wall. And then you draw the first line of the hangman. So everybody knows hangman, you draw the first line. Whenever anybody from the team encounters the same problems, they continue the hangman. Whenever the hangman is complete, the rule is you have to take the sticky note and put it as a task into the next sprint. And then you have to deal with this problem. Now it is where it gets interesting is the following. You not only put those sticky notes on the wall, you also write a lot of dollar signs and euro signs, and you strike them through, or you print out little images of piles of burning money. And you put them onto the board. And then what happens is, and the next morning when the manager walks by and sees a pile of burning money, but they stop immediately and say, "Guys, what is this?" And you say, oh, this is where we lose money every day because those things really annoy us and slow us down. And most of the time the answer is, we need to get rid of those things. Thank you, that was what we told you the last couple of years, but you didn't listen, right? So it's really effective because now, like two things. First of all, now you're speaking their language suddenly. Secondly, you have found just a super easy method to quantify how big the problem is, right? It's just the hangman thing, but it's a form of quantification. So actually, it's a nice little measure you have in order to decide when is the right time to actually do something about those things that are all in our head normally. So the YAG log is a nice little tool to recognize problems over time and deal with them. But obviously, you know, there are also problems we introduce ourselves. And it happens also on greenfield projects. So, right, we've all been there. Clean slate, solid foundations. This time I will build things the right way, right? And a couple of months later you end up with this big thing that is just a big dependency hell and, you know. And I've kind of asked myself, why do we, obviously I'm guilty, right, yeah, like everybody else. And I've asked myself, why do we always end up this way? And what can we do about it? And I noticed a couple of things. I think part of the answer is knowledge. Like, I think in our industry, the knowledge about how to actually make code more maintainable, the knowledge about code design, you know, solid principles are not really understood very well, very deeply, especially dependency inversion and stuff like that. So I think there's one part that we don't really get taught those principles and those ideas a lot. Another part is maybe more like a psychological reason, if you will. So what I did is I watched myself on a bad day, and everybody has bad days. And I just wrote down all the thoughts that come into my head. And now I want to share them with you. First thought that came into my mind was this one. Why should I touch existing code? You know, if you make like a cost-benefit analysis, it's not a good idea, because so I was in a situation where I wanted to introduce a new feature, and I wanted to refactor my code so that introducing the new feature is pretty easy, like in the open-closed sense, basically. So I would have to touch a bunch of files and a bunch of things that were already there. Now, if I mess that up, who is to blame? Me. If I introduce new errors, who's to blame? Me. Right? On the other hand, I don't get faster by doing that. I spend all the time for refactoring, and then I spend a little bit of time for implementing my new feature. I don't get faster. I don't get any benefit really from it. Maybe the next developer working with this part of the code will get the benefit. It's more like a long-term-ish benefit or midterm, not so much short-term. There's no score for me that just goes up, and I don't get like nice street credibility developer points or stuff like that. So I don't benefit a lot from that. So might as well just spread my feature over the files like all the other developers did before me, and not, you know, take the responsibility into my hands to mess things up while the refactoring is maybe gone wrong. So okay, cost-benefit analysis of touching existing code, not so good. The next thought that came into my head is this one. This is kind of the Uncle Bob explanation why we do that. They expect me to be done. We are already too slow, right? Everybody else in the sprint is already working on their third ticket. I'm still on my first ticket, and it even had less story points than all of the tickets that the other ones did. Why am I taking so long? Right? Or the customer is waiting or stuff like that, arguments like that. From my observations, this is one of the strongest factor why people rush things, and they stop when it works, and they don't stop when it's right. So in this case, the only thing I can do is just stop myself from rushing things. And but there's also the opposite, which is this, right? A colleague of mine called this the dopamine rush, he even said drug rush or something like that. So when you're really on dopamine and you have so much fun developing features, and the manager just said, this is what all the customers waited for, and stuff like that, right? So very great and stuff like that. And you go like, yes, it works. And then you want to do the next thing, and yes, it works as well. So you rush yourself, and I noticed this a lot from also teams that I work with, that actually there were no external factors that rushed them. They were rushing themselves. They wanted just to be faster because it was fun, basically. And that's what they said. Right? It's not just my observation. It's also what other people told me. That's just so much fun programming. Okay, this might be a nice place to be in, but it was just so much fun programming that they wanted to get more features, and they don't want it to clean up so much. So sometimes the best idea is maybe just to wait for tomorrow, and especially for merge requests, look at them once again the next morning, and you would discover miraculous things. And yeah, this is pretty much the little warm-up that I wanted to do with you guys about refactoring. I talk about those things in depth with the training that I do at Rohde Schwarz, which is called the Code Cafe, which is interesting because this training I just created myself. I'm not a trainer or anything. I just had the idea one day that, some guys approached me, some team that I was helping with setting up some things, and they just said, could you talk about, we wanted to refreshen all the solid principles and stuff like that. And I said, yeah, no problem, I will do my research, and then I will create a little training. And then they said, actually, it's pretty nice, and it was a lot of fun doing that. Could you do that for other teams as well? And that's how you basically become a trainer in Rohde Schwarz. So it was pretty easy for me to do that, and now I have a lot of fun talking with teams about that from all different programming languages and across the whole company. I learn a lot from them, so it's really, really a fun position and a very interesting position to be in. So if you have questions about stuff like that, obviously hit me up, and you can contact me on that email as well. Thank you very much. Are there any questions?